Find the limit as x approaches 0 from the positive side of ln of x divided by cotangent of x. Now very important here, we are finding the one-sided limit as x approaches 0 from the right side. Okay, so it's very important because, right, if I just asked you what is ln of 0, right, we know that that does not exist. Okay, and same thing, right, if I asked you what is the cotangent of 0, right, the cotangent of 0 in and itself does not exist, but there's a vertical asymptote there, right, for both of these functions. So it turns out that as we finding the one-sided limit, right, once we plug into 0, as we approach ln of 0 from the right side, okay, this is actually equal to negative infinity. Okay, there's a vertical asymptote there. Same thing with cotangent of x. As we approach 0 from the right side, okay, remember, cotangent of 0 doesn't exist, but there's a vertical asymptote there, which is infinity. Okay, so here we have this indeterminate form, which is infinity over infinity. Of course, the negative doesn't really matter, right? But we have infinity over infinity, which is one of the indeterminate forms that allows us to use L'Hopital's rule. Okay, so now we can go ahead. Okay, let's find these derivatives. Right? What is a derivative of ln of x? Okay. Well, the derivative of ln of x is just 1 over x. Then what is the derivative of cotangent of x? That's going to be negative cosecant squared of x. Okay. And you're looking at this and saying, okay, 1 over 0, that's the indeterminate, right? Cosecant squared of 0, okay, that's just 0, right? 1 over 0, though, okay, that's infinity. Okay? So that really doesn't lead us anywhere. It's not an indeterminate form. Okay. So what can we do next here? So here we're going to do a little bit of trickery. We're going to use some algebra. Right? We know that 1 over x, well, that just means, well, x just goes in the denominator, right? If we have one fraction. What about cosecant, right? Cosecant is the reciprocal of sine. So actually what we can do here is we can actually just flip these over, right? Cosecant squared is on the denominator. Well, I know that cosecant squared, right? Remember, cosecant is 1 over sine. So if we take that, that'll actually just come up to the numerator, right? Negative sine squared of x. And then this x, this 1 over x in the numerator, that just comes down to the denominator, right? These two expressions are the same exact thing. Now what happens when we plug the 0 in here? Well, sine of 0 is 0. Sine squared of 0 is still just 0. And then we get 0 in this case. So 0, 0, hey, that's just another indeterminate form. So I know that we can use L'Hopital's rule again. Okay? And that's fine. We can keep using L'Hopital's rule as long as we're allowed to, right? As long as we get an indeterminate form. Okay. Now, what is the derivative of sine squared? Remember, in this case, we have to use, we're going to use a power rule. We'll bring down the 2, right? So we'll bring down the 2 to get negative sine. 2 minus 1 is just 1. But we have to combine that with the chain rule, right? Derivative of sine is cosine. So we get negative 2 sine x cosine of x. And then the derivative of x is 1. Okay. So what happens when we plug the 0 in here? We get negative 2 times sine of 0 is just 0. Cosine of 0 is just 1, right? So, well, anything times 0 is just equal to 0. And there we go. Right? We have successfully found the limit using L'Hopital's rule. In this case, we got the indeterminate form, infinity over infinity. We used L'Hopital's rule once, did a little bit of algebra, and got another indeterminate form, 0 over 0. So we were able to use it again, and finally we were able to get our result.